theta equal to pi, t, see when theta is equal to pi, cos pi is minus 1, so that minus and this minus will make it plus, so we will have r square plus s square plus 2rs. So this is nothing but r plus s whole square. Okay, so this is the upper limit and this is the lower limit. Okay, so we can write down this integration as, so from here I will write, see what is sin theta d theta? Sin theta d theta is actually dt divided by 2rs. 2rs. Okay. So this is equal to, now let me cancel some term, pi will cancel, 2 will cancel, 4 I will get, so I will have qr, then r square minus s square divided by 2, and here t equal to r minus s whole square, r plus s whole square, then sin theta d theta is dt divided by 2rs, then I will have t to the power 3 by 2. Okay, so now this 2rs I can bring outside the integral, so this is equal to so this r and this r will cancel, so I will have q r square minus s square divided by 4 and s. So I will be left with integration 1 by t to the power 3 by 2. So integration of that quantity gives us t to the power minus 3 by 2, actually 1 by t to the power 3 by 2 is t to the power minus 3 by 2. So I will have minus 2 t to the power minus half, so r minus s whole square to r plus s whole square. So this is our final integration. Okay, now this 2 will cancel with this and minus I can take it outside, so minus q r square minus s square divided by 2s, so bracket. Okay, so I will have 1 by, here I have r plus s whole square and it is t to the power minus half, so I have 1 by r plus s minus, now I will have to put, see I can put it as s minus r or r minus s. Now we will see that we have to take s minus r. The reason is that I will make it clarify, that I will clarify later. Okay, so at the end I will say why I am taking as s minus r, not r minus s. Okay, so this is equal to, so net induced charge Q is equal to minus Q r square minus s square divided by 2s. Okay, now I can do the algebra. So s minus r minus r minus s divided by s square minus r square. Okay, so s cancels, so we get minus 2r. So we get, now this minus 2r, this minus will make this minus to be plus. So we'll have, so q r square minus s square divided by 2s into 2r divided by, see, minus 2r actually, that minus and this minus make it plus, so s square minus r square. Okay, now these two cancels. Okay, now see, here I have r square minus s square, here I have s square minus r square. So if I change, so one minus sign will come. So minus q r square minus s square into r divided by s. Now I have changed it, so r square minus s square. Now this term cancels, so we get minus q capital R by s. So the net induced charge is equal to the image charge, because we took the image charge to be minus small q into r by s. So the net induced charge is minus q r by s. This is the net induced charge on the surface of the conducting sphere. Now you can see that if I would have taken r minus s here, then I would have a plus sign here. So since we know that the induced charge should be a negative charge, because outside we have a positive charge plus q outside the conducting sphere. So that, see, I have a conducting sphere here, here I have a positive charge plus q. So this plus q charge will induce negative charges on the surface of the conducting sphere. So this net induced charge should be negative. So I have taken this to be s minus r. Okay. So today what we have seen, we have placed a point charge in front of a grounded conducting sphere, and we wrote down the expression of the potential outside the sphere. We calculated the net induced surface charge density, and also we calculated the net induced charge. We see that the net induced charge is equal to the image charge which we took. Okay, so this much is for today. We stop here. Thank you.